Alright, now we're moving on to question 2 from the practice exam. This one, it says, this question is concerned with the design and implementation of classes for a school bus transportation system. It says, in this system, a student object represents a student in a given school. Student has a name and an address, represented as a street name, which is a string, and a house number on the street, which is an integer. The class student implements the following interface. So student implements the interface for a person. So the person interface, as you can see in your text, I'm just going to write it up here on the screen pretty quick. So remember, interface means that anything that declares itself as a person, that's a little too generic. We want anything that says they're a person, they have to be able to give you this information. Okay, it's that sort of signing a contract. If you are a person, you need to tell, you need to use these methods and declare how they actually work. We're not going to declare them because we don't want to be building any generic persons, so to speak. We're going to have more specific versions of this. And so student class is going to implement this interface, so they will have a get name method that actually works, a get street method, and a get number method that all work. Okay, so we are then tasked, given the task of writing the distance method. It takes in a parameter for a student object called other, and it says if this student lives on the same street as the other student, then the distance returns the absolute value of the difference in the numbers of their houses. Otherwise, it returns 99999. Alright, so let's just kind of, again, picture what's going on here. So suppose we have two streets. You got houses up and down the street. Maybe this is Main Street here. And we've got one house at 100 Main Street. And we've got another house down the road at 127 Main Street. Okay. Then over here, we have a house on, we'll call this, I don't know, just trying to think of a made-up name for a street here. We'll just call this, I don't know, Clark Avenue. Sounds like a real name of a street. So over here on this other street, we have a house. Let's say that this is at number 230. So 230 Clark Avenue, and we've got these other houses on Main Street. So according to this description, it says if this student lives on the same street as the other, then the distance is the absolute value of the difference in the number of houses. So suppose we have a student here, and a student here. Alright, we'll call this student A, student B, student C. So if they live on the same street, distance is supposed to return the absolute value of the difference in the numbers of their houses. So for instance, from house 100 to 127, the difference there is 27. Okay, so if I'm comparing student A dot distance to another student, like student B, then that's going to give me 27. That's what's going to be returned. And vice versa. So it's using the absolute value. That way we don't ever end up with like a negative distance when we're comparing these. The distance is always considered a positive value, an absolute value. So, oops, I need to put semicolons there. So then if we look and compare it to maybe student A, figure out the distance between student A and student C, well, this is an interesting case because if they are not on the same street, we can't use the house numbers to determine this. It says it should return, if they're not on the same street, 99,999. Okay, 5 nines in a row. That's just the default to represent houses that are not on the same street as one another. So we're supposed to complete this method. So the method header begins public int, because we are returning the distance as an integer. And it takes in a student object called other. Now think about what's going on here. It says this distance method is a method, this is the first line of the problem statement, part A. It says write the distance student other method of the student class. So since it's in the student class, this refers to when we have a student object. Okay, and we're comparing it to another student object. Alright. So the only time we actually want to calculate the distance is if the two students are on the same street. So if I want to get the street of this current student, Okay, not the other one, but the current one that we are referring to when we call this method. So for instance, like here, student A would be the current student we're looking at. Student B would be the current student, and so on. And then we compare those together. So if I get the street name, and since student implemented this interface, I'm guaranteed that there is a getStreet method in the student class. So if I say if getStreet, which is going to get the street of the current student that we're focused on, that returns a string. So I want to see, are we on the same street as the other student? Okay, so if I'm comparing strings, street names, I need to use dot equals to compare those. So if getStreet of the current student equals the street name for the other student. Now think about this. getStreet by itself gives us the street name for the current student. If I want the street name for this other student here, I have to put the name of that object, name of that student, which is other, then say dot getStreet. Okay, works the same way. We just have to use the dot notation since we're referring to a different object than the current student. Okay, so if the street names match up, getStreet equals other.getStreet, then I want to simply go through and figure out what the distance between the two is, between the two houses are, and then return that. So I'm going to do this in one step. So there is a method. This is on your handout. Okay, remember you'll have that AP Java subset handout to give you assistance, remind you of some key methods that are useful, methods you should know, like the methods from the math class, methods for strings, general methods for lists, information like that. So if we're talking about absolute value, there is a method in the math class called math.abs. Remember, math class is static. All the methods are static, so we use the math.abs notation here. And the way it works is you just simply, if you want the absolute value of something, just tell it what you want the absolute value of. We want the distance between them, so if I just subtract these, it doesn't matter the order, but I want the number of the first student's house, the current student's house, minus the number of the other student's house. So if I call getNumber, it's the number of the current student's house, and if I subtract the number of the other student's house, remember this only executes, this only happens if the streets were the same. So I get my number, get the other student's number. If we subtract those to find their difference, and then we call them absolute value, math.abs. Okay? So that returns the absolute value. The only tricky part is, and if you look at your handout that has this information on it, that AP Java subset handout, it actually mentions that the math.absolute value returns a double. Okay, most math methods return doubles. So if I want to return a double, or since this returns a double, but I want my distance to be an integer, I need to typecast this. So I'm just going to say, once you're done doing all this, turn it into an integer. Okay. To be safe and make sure that it figures out everything, it doesn't just turn a part of this into an integer. It won't. If you look at how you wrap this together, math.abs takes in all this information and returns a double in itself, so this is enough. But if I wanted to take like a final answer and turn it into an integer to be safe, I would always be welcome to just put an extra set of parentheses around everything. Okay, so that it does all this, then turns the answer into an integer. But that's a sort of safety net. We don't need it in this case. And so that finds the distance and returns it. Now what happens if this statement was not true? What if they're on separate streets? What do we want to return as our distance? Well, if you remember, it told us to return that number with 5 nines, so 99,999. So if that is not true, this part gets skipped. That must mean they're on different streets, so then we want to return that number right there. Okay? And that's all we need to do for this first one, to find the distance between the two students. All right? So just be aware this is going to be useful. We will see this as we move through. If not question B, question C will definitely bring this back up.